So good afternoon, everyone. Thank you very much for taking the time to listen to my presentation, and I hope you get something from it. So the title of my project was Iron Deficiency is Prevalent in Irish Female Athletes, while Iron Excess is Prevalent in Irish Male Athletes. So the format of my presentation will be very similar to the format of my write-up. So as you can see on the screen, it starts with background and finishes with discussion, and then I'll conclude with some future recommendations. So iron deficiency, is it a problem? Well, the answer is yes. 33% of females of reproductive age around the world have iron deficiency, making it the most common nutritional deficiency in the world. In terms of athletes then, there's a lot of research to suggest they have an increased risk of deficiency for four main reasons. The first is relative energy deficiency. Secondly, exercise-related iron losses. So examples might include foot strike hemolysis or gastrointestinal bleeding. Thirdly, there's an upregulation of the hormone hepcidin, which increases and peaks at about 3 hours following exercise, and this inhibits iron absorption. And then lastly, menstrual losses, which amount to about 1.6 milligrams per menses, putting the female athlete at a greater risk. So why is iron important? And I suppose first and foremost, it's very important for oxygen transport, especially to those working muscles. Next, it's important for energy production at a cellular level, so in the mitochondria. Immune function is very important, so trying to reduce those exercise or the training losses from illness. And cognitive function. All of these four items are very important to sustain high levels of performance. But despite this biological importance, up to 59% of female athletes have a risk of iron deficiency and 31% of male athletes. So it's unclear from the research whether iron deficiency without anemia results in performance declines, but it's undisputed that iron deficiency anemia results in a whole host of symptoms, which undoubtedly result in a decline in performance. And despite this, up to 18% of female athletes have iron deficiency anemia and 7% of male athletes. So bringing it back to home, what is the prevalence of iron deficiency in our athletes? And the answer is we don't know. And then if we look at our para athletes, again, we have no prevalence studies internationally or in Ireland. So to try and answer those two questions, I looked at my project and tried to create four main aims to help answer those questions. So the first is looking at blood samples to assess the iron status of our elite athletes, to create a list of high-risk athletes, to establish the impact of 19 months of nutrition and medical services provided at the Irish Institute of Sport, and then to try and apply my learning from the project and develop a protocol which could be used in future to screen for iron deficiency. So very briefly, my methodology. So before I entered the project, athletes were enrolled in the Irish Institute and consent obtained. Blood samples were taken repeatedly over a 3-year period, and nutrition counselling was provided as required over that time. Then I created some categories for athletes, which I'll talk about in the next slide, and I analysed the results. So athletes were categorised into able-bodied athletes or para-athletes. An additional classification was assigned based on 12 different sporting disciplines, and on-feet or off-feet athletes, and running distance. Iron status was assessed using ferritin, hemoglobin, hematocrit, and then folate and B12 were also investigated to outrule anemia, which is unrelated to iron deficiency. And then because there's a large variation in ferritin and hemoglobin, additional parameters were also looked at, so hydration status, inflammatory markers, and markers of muscle damage. Reference ranges, and this is a big problem. So reference ranges for iron in athletes is very poorly established. And a lot of the researchers to date have used reference ranges for the general population. However, this guy, Pete Peeling, is different in that he has developed reference ranges for athletes in particular, specific to iron. And I've used his reference ranges in my study. So he looks at breaking down iron deficiency into 3 stages based on severity, using ferritin, hemoglobin, and transferrin saturation. Unfortunately, transparent saturation wasn't available in this project and it was therefore excluded. This classification was originally designed for the female athlete, but I amended it to include male athletes. And I also added 2 additional classifications for normal iron stores and iron excess. So the exciting part, what were my results? So first of all, you'll be glad to hear that none of our elite athletes have iron deficiency anemia. However, our female athletes have 34.6% stage 1 deficiency and 3.8% have stage 2 deficiency. And the ferritin levels of these female able-bodied athletes were significantly lower than any other group that you can see on the screen. When we looked at what happened over a 19-month period where athletes received nutritional counselling, there was a statistically significant reduction in stage 1 deficiency to 14% and a complete eradication of stage 2 deficiency. When we looked at sporting categories, no athlete, regardless of the sporting discipline or sporting category, had any increased risk. So a very surprising result was that iron excess was very prevalent in our male athletes. So if we look at our para athletes, 57% had iron excess, and these athletes had statistically significant higher ferritin levels than any other group. Looking at our able-bodied athletes, 16% had iron excess, and over a 19-month period of nutritional counselling and medical services, that actually increased to 36%. So our fourth and final result came from multiple regression. So we know that hemoglobin is based on your whole blood. So variations in plasma volume from a result of dehydration or overhydration can affect the hemoglobin level. And in this study, I found that hydration and muscle damage was responsible for 24% of variance in hemoglobin. And these results were statistically significant, which I suppose reinforces the importance of controlling for these limitations when you're assessing iron status. So in discussion, our Irish female elite athletes have a very high prevalence of iron deficiency. And when we compare them to other elite athletes, Irish athletes have 3 additional risk factors for iron deficiency. Firstly, there's a very high prevalence of celiac disease in Ireland, and undiagnosed or untreated will increase the risk of malabsorption of iron. Secondly, dietary intake of iron in females in Ireland is known to be in RDA, or the 18 milligram RDA for athletes. And thirdly, in Ireland, we are Europe's largest consumer of tea. So if you have a very high consumption of tea, you're increasing your risk of malabsorption of iron. On the complete opposite end of the spectrum, our male elite athletes have a high prevalence of iron excess. And when we try and ask ourselves why this is, well, first of all, maybe it's because of the increased nutritional counselling and the excellent and timely work of those at the Irish Institute. Secondly, with an increased acceptance of the role of iron in performance, there's an increase in iron supplementation, and it's becoming common practice. To note, I suppose, is that at the present time, the Irish Institute recommend iron supplements for ferritin levels that are less than 50, which is well within the normal range. And while supplementing at this higher threshold is likely to have reduced the prevalence of iron deficiency, it's also possible that it may have contributed to iron excess, and I suppose warrants further investigation. Thirdly, hemochromatosis is one of the most common genetic disorders in Ireland, which increases the risk of iron overload. And while we don't know what the prevalence of hemochromatosis is in our Irish athletes, blind supplementation should certainly not be recommended. So I said that one of my aims was to try and apply my learnings from this project and develop a protocol. And here is an example of a protocol that I developed. So first and foremost, because no athlete, regardless of sporting characteristic, had an increased risk of deficiency, all athletes should be considered equal in terms of risk, and therefore all athletes should be screened. So then once they start the screening process, Athletes should avoid eccentric exercise for 48 to 72 hours prior to testing. Testing should be done in the morning. Inflammatory markers like CRP or white cell count should be checked to outrule infection or inflammation. Hydration or adequate hydration should be ensured. And as a minimum, ferritin, transferrin saturation, and hemoglobin should be checked and should be added to any blood protocol. So there are several limitations in my study, like there are in any other study, but I suppose I've put this here just to acknowledge that I do have limitations and to try and reduce them in future. I've added them to either the protocol that I've just mentioned previously or added them to future recommendations in my final slide. So to conclude, this is the first study of its kind in reporting the iron status of Irish athletes, and also the first study of its kind in reporting the prevalence of iron deficiency and iron excess in para-athletes. In Ireland, our female elite athletes have a high prevalence of iron deficiency, and engaging in nutritional counselling like that provided at the Irish Institute is a successful way to try and reduce deficiency. On the opposite end of the spectrum, iron excess in our male athletes is very prevalent, and blind supplementation should therefore be avoided. So in future, what kind of questions should we be asking ourselves? The first is, what is the performance impact of iron depletion in our female athletes? Secondly, what is the prevalence of hemochromatosis in male athletes? Thirdly, why are there differences between able-bodied athletes and para-athletes in terms of iron status? Fourth, what are supplementation practices across our elite athletes? And finally, what is the quality and quantity of dietary iron intake in our elite athletes? So I'd like to take this opportunity to thank everyone involved in my project. So in particular, Nora, who's my clinical supervisor, and who, without this, I couldn't have completed it or got it to this point. I'd also like to thank Sharon and Ciara from the Irish Institute, who provided the raw data and were on hand to answer any questions as they arose. And that's the end of my project, and I'd like to open it up to questions.